Okay, we're going to look at this example. It's going to go kind of fast. Maybe. I'm hoping that it'll go. Ooh, I just popped my neck. I think it's going to go kind of fast. So when I say maybe pause it and think about it, you should pause it and think about it. Otherwise, it's going to not make sense at all. So let's read it. For theta in the interval, this means an element of. For theta, an element of the interval or the set from 0 to 2 pi, not including 2 pi, including 0. So those are the values that are allowed for theta. So for theta in that interval, determine all values of theta at which the tangent to the polar curve r equals 1 minus sine, so that's what I'm thinking of, is horizontal. Now after this, I'm going to see if I can draw the graph for you. So I'll just graph it on my calculator or something. But first, we must know if the tangent is to be horizontal, that means the slope of the tangent line is 0. It's 0. It has a slope of 0. But I also know the formula for dy dx. So what's happening is I want to know, because for a fraction to be equal to 0, the numerator has to be equal to 0. So to rephrase this question, I actually want to know where this is equal to 0 and this does not equal 0. Because if they're both 0, then we'd have to do some other things. It's an indeterminate form, so we'd have to see what happens at that spot. Maybe there's like a cusp or something. But so let's look at this. To reword this question, it's asking when is dy d theta equal to 0 and dx d theta not equal to 0. So that's what I'm going to try and do. The first thing I will do is write down what y is. Remember, y is going to always be equal to r sine theta for polar coordinates, and they give us what r is. So I'm going to say y equals r, and then put on whoops, I already have this, that's r. Now I'm going to tack on the sine theta. Now what I am going to do is, I'll get the derivative of this, and it's using product rule. I'm just going to write the derivative down, so maybe you want to pause it and calculate the derivative for yourself, but then I'm just going to write it down, and hopefully you get the same thing. So I used product rule. First, d second plus second, which is that one, d first. The derivative of negative sine is negative cosine. So there we go. Now I'm going to do the same exact thing for my x's. I know that x equals r cosine theta, and I know that r is that thing. So there is r, and I'm going to tack on my cosine of theta. And now I'll find dx d theta. And same thing, you might want to pause it, try it on your own, and see if you get the same thing as me. So here we go. I got first, that's this, d second, the derivative of cosine is negative sine, plus second, which is that part, second, d first. So the derivative of negative sine is negative cosine. So there we go. Now, I have all of those. I want to see, what am I doing? Find the thetas for dy d theta, that's this, equaling 0. So I got to figure out when does this equal 0. So I will manipulate it. That's my question. And I'll write it over here. So I wrote it over there, and now that's what I'm going to try and answer. When is that equal to 0? That's dy d theta. I'm going to figure out when that equals 0. And I'm just going to factor at first. I see that there are cosines, so I'll factor out a cosine. And then I will combine like terms. So factor out the cosine, now I'll combine like terms. And now I can use the zero product property. This is actually asking when is cosine of theta equal to 0. And then also 1 minus 2 sine theta. When is that equal to 0? Now if I added this over to the other side, then divided by 2, I would get sine theta equals 1/2. So what are the theta values that give me 0? And remember, theta is only allowed to be from 0 to 2 pi and not including 2 pi. So cosine is 0 at pi over 2, and also at 3 pi over 2. Those are just things you know. Verify that with a unit circle or your brain, because I know they're in your brain. And then when does sine equal 1/2? Well, that'll be at pi over 3, I think. No, pi over 6, and also 5 pi over 6. Let me just think about that while I pause it. Yep, instantly. Okay, so those are my possible values. However, I do have to check and make sure that. So I found out all the thetas where this is true. Now I have to make sure that this is also true. Because if it isn't, then it's not really horizontal. Something else is happening. So let's see here. Let's check pi over 2. If we put in pi over 2, I'm just going to plug it in to this and see if I get 0. If I do, that would be bad. So sine of pi over 2 is 1. So this would be negative 1 minus 1. There we go. So this piece goes away. I don't even have to figure. I mean, that's just 1, but so that piece goes away. So actually, when I plug in pi over 2, it doesn't work out. So I don't use that. Okay, what about 3 pi over 2? That gives me negative 1 if I plug it into sine, right? So that would be negative 1 minus negative 1 times negative 1. That's not 0. Minus cosine of 3 pi over 2. Those are 0. That goes away. So that's fine. But, I forgot. Wait, so this would be, I mean, I didn't check this part, but I knew it was going to go away anyway. So let's go back to checking pi over 2, because I missed some things. If I plug in pi over 2 here, I get 1 minus 1. This piece goes away. If I have, I should have not closed out. So if I plug in pi over 2, that part cancels out. And then if I plug in pi over 2 to cosine, that goes away as well. So it's a 0 and a 0. So that's why I cannot use pi over 2. Now if I plugged in 3 pi over 2, that should be okay, because I get negative 1 minus negative 1, right? Because sine of 3 pi over 2, that's on the bottom of the unit circle. So that gives me a negative 1 times a negative 1. And then this goes away still, because cosine of 3 pi over 2 is 0, so that part is okay. But it's 0, but that part isn't 0, so the whole thing, would that be 2? Just positive 2, so that's not 0, so that one works out. And then we just check for these, and I think you can verify for those that those actually work. They're completely fine. If you plug it into both of them, they're fine. It doesn't give me zeros at all for anything. So, there you go. It is important. I mean, you should check those two to make sure that they work, but they do. And if you have any questions, let me know. But those are, so that's my answer. It's saying find the exact values of theta for which the tangent to the curve is horizontal. So that means that 3 pi over 2, pi over 6, and 5 pi over 6. And if we were to graph it, hopefully we'd see those 3 spots. So we do have a cardioid. That's what the graph would look like. It looks like a little apple. So what happens here? If I'm pretending to graph this, so this would be theta is 0, and then I'd start wrapping around. It probably goes to this first, maybe. I'm guessing. That's a completely guess. But the first time it would happen would be at pi over 6, right? So if this angle comes out to pi over 6, something happens. It'd be easier to see on a graphing calculator and actually have it graph it sequentially. But if I plug in 0, I get 1, right? So it actually starts here, and then at pi over 6, we have this horizontal tangent. And then at pi over 2, we do have a cusp. So that's when we got 0 over 0. And then you continue on, and at 5 pi over 6, that's this one, right? I think. Yes. At 5 pi over 6, we get another horizontal tangent. And then we keep going around, and at 3 pi over 2, we get that. And then it continues all the way around. So there you have it. Good day.